Okay, this is the video for the second packet. And just so again, a few selected problems. So let's go ahead and start with the first one I selected, the number 3. Now for this one, it's asking you to find the zeros of the function. Now again, when you have a quadratic, you got to make sure there's two numbers that add up to the middle term. Since a equals 1, two numbers that add up, that multiply those same two numbers that multiply to this on c. You would get negative 5 and 2, so this factors this way right here. Now what they want is pretty much when you make these equal to 0, these numbers will make the entire equation 0. So if you plug in x equals 5 back here, you're going to get actually something that gives you a 0. Same here. So you actually find your zeros when you find it. So if you go here and you check them, 5 for positive 5 and negative 2 for this one, and so the other ones wouldn't give you the 0, so they're trying to trick you, whether it's negative 2 or positive 2 or negative 5 and positive 5. And so those two would work, the other ones wouldn't. And I show you on the answer key that if you plug these in, you get some other number that's not 0. Alright, so that's this one. And then let's go into this other one here, right here. Now these two, I just wanted to point out, there sometimes you get linear systems, so they're linear systems. Now you got to make sure to read the information carefully, because once you get the information, I was able to get this piece of information, write two simple equations. The t-shirts and the hats equals, the t-shirts and the hats equals 23, and so, and then $10 per hat plus $12 per hat. I mean per t-shirt, $10 t-shirt plus $12 per hat equals $246 as the amount of money they made. You can solve for t or h here, plug it in, substitution for that one. And here, this is another piece of information. You read it carefully, you can get two equations used in new type video games. 4 used plus 2 new equals $82 for the first one. And then here, 6 used and 1 new equals $78 for the second one. You can solve this by elimination, multiply the bottom one by negative 2. I show you on the answer key how to do that. So sometimes you get linear systems, problems like that. Moving on, we go this one right here. This is a classic shifting for type of problem. Now, anything that affects the x in the parentheses will make it shift left or right, and it's the opposite. So if you see a negative 4, you're gonna see here that you're gonna go to the right. So in here, it's the opposite. Okay, so opposite. For this one, it's as is, as it is. So if it tells you positive 2, it means you're gonna go up positive 2. Now this, the one that's outside, tells you how you're gonna move up or down. If this was negative 2, you're gonna move, that'll be 2 down. If this was positive 4, that'll be 4 to the left, kind of the opposite of the negative. Okay, so for this one, it's gonna make your parent one, this original one, this right here is this original one here. So it's gonna have the same shape, the same graph shape, just translated. 4 to the right and 2 above. So that's going to be your new shape. This is actually, so let me get rid of here. For this parabola, it's this equation. There you go. Plus 2. That's this equation for this parabola. For this parabola, it's the original, just parent graph. Not altered, just as it is. Y equals x squared. Right at the origin. And then this little shifting goes on, that happens there. So there you go, that's actually number 7. It's pretty straightforward for that one. Let's go to the next one here, a series of them, almost there. This might end up to be like 6 minutes long. I'm gonna see if I can get it earlier. Okay, for this one, it's pretty straightforward. If you have something a is positive, you have a parabola facing up. If your a is negative, you have a parabola facing down. So this is a parabola facing downward. All of the positive ones get canceled right away. So this positive A, out, out. Negative A, negative A, negative A, negative A still in. Now one thing also about these is that your C will always be your y-intercept. This is a general quadratic. Your C will be a y-intercept. So if you kind of zoom in here for the y-intercept, it should be 5. You see a y-intercept of 3, of 6, of 3, and of 5. So since they all kind of cancel out with this, there's no other option than that one over here. And that's your answer. There you go. For this one here, every time you see a quadratic, people, you got to know a quadratic, one of the variables squared, you must factor. That's exactly what happens here. This looks a little weird, but if you factor, you notice that this will turn into that. And then look at the answer key to how to factor for this. And you see the n-1, n-1 quantities cancel. You get something easier to manage, and you actually cross multiply to finish that up. So that's no problem for that one. Just always factor with quadratics. Okay, factor. And then here you have something of a complex problem, but not really. Label your base and label your height. So you have here your height 2w plus 17 as this one here. And I'm sorry, your base right there, because it's 17 and then a little w there, a height with 2w plus 13. You have it here as well. Okay, you have that for the height. That's the expression, because you have a 13 and a w and a w right there. So you have to understand, you got to write your area equals base times height. Just plug in what you have. Your base is this, your height is that, and your area, they give it to you 396. Just right there. Okay, so moving on, almost there for this one. For this one here, let's just go ahead and look at the answer key for this. This is like a general form for this equation, how to set it up. But you can kind of just see that there. It's actually well explained in the answer key, so I won't spend that much time for this one. I do want to spend some time here for this one here. This, if you ever see an equation like that, that's cross multiplication to solve for that. Okay, this is something linear, something easy. Solve for x, meaning combine like terms and solve for x, very easy. When you see a radical equation, you want to isolate your radical. So this 6 is outside the radical. Move it over. You want to undo a radical by a square, and then you get something easy here, and you solve for something. Again, to put the answers here, this will be so since we got one solution, probably one solution, so one real, and then that one turned out to be infinite. And you'll see in the answer key why. Here as well, when they tell you not equal, cannot equal, meaning you cannot divide in by 0. So whatever makes this 0, whatever x makes it 0, you want to make sure you want to not pick those. Okay, this is an interesting one, because actually here there's no division, so therefore you don't have to worry about dividing by 0 for that one, and they all work out for that one. Okay, so almost there, trying to make it under 9. Almost is kind of like the most. There's only one more left. All right, right here. Sorry about that. Here it is, the last one. So something simple like this, sine of b, you want to make sure you're always labeling for your trigonometric problems there. And then that's it. 3/5 would be the answer. Very easy. Some of them are pretty straightforward like that. And then the last one here, they tell you, I like this problem because you actually have to do a Pythagorean theorem to solve for this little x here before you actually do all these. And it turns out to be 12. And then once you set up your true trigonometric ratio for all these three, you just use it to eliminate answers. So some of these will be wrong. You can clarify, because this is the real ones, and you're cross-referencing to this when you're eliminating that. So there you go. That's it. Pretty lengthy, but there you go. Have a great day. I'll see you tomorrow.